algorithm says that always access that track which seek time is very less. So, in our previous problem, we moved from 53 to 98, but here we move 53 to 65 because the seek time is less. Now, from 65 to 67, seek time is very less. So, first we have to consider from the current head pointer to the nearest head number, track number, because our target is to allow less seek time. In similar way, from 67, we can travel 14, we can travel 98, we can 22, 24, and 83. But I see very simple that if we move from 67 to 14, the seek time will less. And the calculation of head movement is same as from 53 to 65. That means 63 minus 53. 67 to 65. That means 67 minus 65. 67 to 14. That means 67 minus 14. In the same way, if when we at 98, we move to 122 because 98 to 122 is less considering 124. Now we are in 122, so we have to move to 124, and last the tag number is 183. So our 60 हम कहाँ है 67 पे है, तो this movement क्या है 98 to 67 है, 98 से कहाँ गए हम 122 में, that means 122 minus 98 है, 124 minus 122, and lastly 183 minus 124. If we sum up, we will get 240. So if we compare between FCFS and SSTF, we can easily conclude that the SSTF is more and more better than FCFS because head movement is 240. So, which is very less than FCFS considering the same problem. Now, we will discuss another algorithm for this scheduling which is known as CSCAN. Now, before discussing CSCAN, we have to understand SCAN algorithm. SCAN algorithm states that from the current head pointer, we have to go to the one end of this, then again we have to move forward. Thus, this algorithm is also known as elevator algorithm. So, first starting from 83, we find nearest is 37, then nearest is 40. But now the changes is we have to go to the starting, that means track number 0. From 0 we can go forward direction 65, from 65 to 67, then 67 to 98, and 98 to 122, 122 to 124, and again 183. Actually, this is more optimal than previous two algorithms, because if we calculate 63 minus 37, then 37 minus 14, we will get just 208 head movement. But previous one was 240 and first one is 640. So this is more optimal than the previous two. Now we are discussing the more popular version known as CSCAN. Actually, CSCAN is nothing. C is for circular. The term is circular scan. Circular scan means the considering the same problem, we will discuss CSCAN. In CSCAN algorithm, we start from 8 pointer 53, then we move 65, then 67, because we have to move to 18. Then after reaching the last pointer, we circularly move to the 0 sector. So 53 to 65, 65 to 67, 65 to 98, 98 to 122, then 124. But after reaching 183, we have to go to the end of the disk. 199 not given a odd cube, but according to this algorithm, we have to reach to the end of the disk. Then this line shows that actually this line doesn't take any time. From 199 to 0, just imagine it as a circular pipe. So it just moves to the 0 sector without expensing or without taking any time. So when we calculate the 8 pointer movement, we consider 65, 53, 67, 65, but we never consider 199 to 0. This is the very advantage of this scheduling algorithm. And lastly, 183 to 124. 192 means the last pointer to 183. But from 199, we just reach to the sector 0. So from 0 to 14, that means 14 minus 0. And now 37 minus 14, that is 23. If we sum up this figure, we will get 183 is the total disk movement. If we compare 4 algorithm, this is the most popular and optimal algorithm. Nowadays, maximum disk company maintain this kind of algorithm to calculate the minimum head movement, and this is more efficient algorithm implemented by the more disk company. So no more today. We discuss total 4 algorithm in the scheduling algorithm.